And the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so eventually today we're going to go on to section 6.2. But before we do, I have some questions from a student. So we're going to take a look at those, which is why I've got WebAssign up there. So let's go to a blank page here. And this is from section, come on, there we go. Oh, it's still in red. That's all right. Section 6.1, and we're going to take a look at number 17. I'm going to change the color because I think black shows up better than red does. Okay, so number 17, it says factor the polynomial. So you can see here where the x's are, or it's incomplete. So the student had questions about this. Notice though, you don't know who it is. Okay, factor the polynomial by factoring out the opposite of the GCF. Okay, so we've got negative 8a squared plus 12a. Also, notice that there's numbers that are in red, like the 8 and the 12. Everybody has the same assignments, sort of. The numbers that are in red may differ from one student to another. So your problem number 17 may not look exactly like this, but it's the same type of problem. Factor the polynomial by factoring out the opposite of the GCF. All right, what goes into 8 and also goes into 12? 4 does. What goes into a squared and also into a? 8. Okay, now notice they wrote 4a, but they wanted the opposite, so they wanted a negative factor taken out, greatest common factor. And I know it's a little confusing. When the directions say find the greatest common factor, then you would write just negative 4a or 4a, depending. But it wants you to factor it out, meaning you still have what's left over. So that's why we've still got the 2a minus 3 in parentheses. Is this correct? Well, of course, you can see that it is up there, but if I multiply it out, I get negative 8a squared plus 12a, and there's nothing common in here other than a 1. So negative 4a times the quantity 2a minus 3. Any questions on that problem before we go on? Okay, let's take a look at number 18. Factor the polynomial by factoring out the opposite of the GCF. So basically the same directions. Negative 27a to the 5th minus 63a to the 4th plus 18a cubed. So I know I'm going to take out a negative, okay? Now, if I look at the coefficients, the 27, the 63, and the 18, the largest number that's a factor of each of those is 9. If I look at a to the 5th, a to the 4th, and a cubed, the largest power of a that's a common factor of all of those is a cubed. So there's my greatest common factor. Any questions so far? All right. So negative 9a cubed times what is negative 27a to the 5th? And that would be what? 3a squared. And if you can't do it that way, you could also say, well, what's negative 27a to the 5th divided by 9a cubed? And that's where you'd get your 3a squared. So you can either say this times what, or this divided by this gives you what. Okay, just like, let's say you have the number 8 and it's 2 times what? Well, you could say 8 is 2 times 4, or you could say 8 divided by 2 is 4. Either way, okay? All right, so what's left over? Well, let's see here. Negative 63a to the 4th, we need what, a plus 7a to get negative 63a to the 4th. And then here, negative 9 times negative 2 would be positive 18, and we've already got a cubed. So negative 9a cubed times 3a squared plus 7a minus 2 would be the final answer as we see it is there. Any questions about that one? Okay, that takes us all the way down to number 27, factor by grouping. 6.1, number 27. So we've got 4t cubed plus 6 plus 8t squared plus 3t. My suspicion is that that thing is not going to factor in its current form. We had one like this yesterday. So I'm going to put it in descending powers of the variable first. Then I'll break it up into two groups of two terms. The greatest common factor of the first two terms is 4t squared. So I have a t plus 2 left over, which means that the next group, I have to have a t plus 2 left over and a plus 3 outside for it to work. So now I have t plus 2 times 4t squared plus 3. Again, any questions on that process? Russ, yes or no? Just, you're okay?
Just give me 1 second, because these are all the same ones I had problems with, so I would copy the example.
Not a problem. We shall wait for you to tell us to go on.
I hate when t is used as a variable, because my t's and plus signs look the same.
Oh, absolutely. And this t right here kind of looks like a 4 with a tail. My writing is atrocious.
All right, I'm all set. Thank you.
You wouldn't believe I got an A in printing in first grade, but in sixth grade cursive, there's a reason it's called cursive. Anyway, okay, let's see. This is 27. We're going to go on to number 28 now. And factor by grouping. Again, we've got x cubed y squared minus 3x squared y squared. Sorry, I should have put so much distance there. Okay. Let's see, minus 3x squared y squared plus 4xy squared minus 12y squared. All right, well, looking at it, it's like, is it going to work? Am I going to need to arrange it? It's actually in standard form in terms of x, because the first term has x cubed, the second term has x squared, the third term has x, and the fourth term has no x at all. So I think it's already in a standard form. Let's see what happens. So split it up into two groups of 2. The greatest common factor of those first two terms would be x squared y squared. The leftovers, we need an x minus 3. Okay with where I'm getting that? So that means over here, I need an x minus 3. Remember, don't look up, look over and clone it. So what would be outside? Oh, you know what I overlooked? There's a greatest common factor for all 4 terms. Yeah, y squared. So gonna go back and we'll get rid of this. So I didn't catch that. See there? Everybody has a y squared in it. So we're going to take out a y squared, and then we'll have x cubed minus 3x squared plus 4x minus 12. Okay. So far, so good. Now I'm going to take what's in the parentheses and use factor by grouping on that. So I'm going to have y squared, then I'm going to change it to brackets just so we keep things straight here. The greatest common factor of x cubed minus 3x squared would be x squared, and the leftovers would be x minus 3. Okay. So over here, I'm going to have x minus 3, and I'm going to have a plus 4. That gives me 4x minus 12. So now I've got y squared times x minus 3 times x squared plus 4. I want to point out something I mentioned yesterday. If you look over in WebAssign, you see how their answer doesn't look exactly like mine? They've got the y squared over on the right-hand side. They're equivalent though, because remember, multiplication is commutative. So like 2 times 3 times 4 is equal to 3 times 4 times 2. You can move things around as long as they're all being multiplied. Okay. We good to go on that one? Okay, so 33 coming up. Again, 6.1, number 33. And we have 6a squared b plus 18a squared minus 12ab minus 36a. Well, after that last problem, I'm a little more awake. So I'm going, oh, wait a minute. There's an a that's common to all 4 terms. What is it? Fool me once, shame on you. Fool me twice, shame on me. Something like that. Anyway, so I'm going to take out an a. Oh, but what else is common? A 6. 6 goes into 6. It goes into 18. It goes into 12. And it goes into 36. So my greatest common factor that I'm going to take out of everything is a 6a. Okay. So now I've got what? ab plus 3a minus 2b or not to be, and then minus 6. Okay. So far, so good. Now, I've got to be careful that my b's don't look like 6s. So this is a 6 here. So now I'm going to use factoring by grouping on the inside. So I've got 6a. Greatest common factor of those 2 terms would be a, with leftovers of b plus 3. So here my leftovers are going to be b plus 3. And I need a minus 2 to get my minus 2b minus 6. Okay. So now I've got 6a times b plus 3 times a minus 2. And again, you can see their answer isn't in the same order, but I could commute the a over here by the 6, etc. Yeah, that's kind of unusual the way they wrote it, because typically you would write the 6 and the a together, but this is also correct. This answer here, not the one over there. But oh, you know, and this situation right here, if you multiply it out, you get the correct original thing. What's wrong with it is they didn't take out the greatest common factor first. For instance, look at this first factor. You could pull an a out of both of those. So that would bring the a out and would leave you with a b plus 3. And the second factor, you could take a 6 out and it would leave you with the a minus 2. So what they did, it isn't finished. You want to look for that greatest common factor first. Otherwise, you may tend to forget it later. Okay. And finally, 35b. It says factor. So this is part B. And we've got 8x squared plus 8xy plus 8x plus 8y. Well, it's obvious to me, even in my half asleep mode here, all the 8s are red. It looks like every term has an 8 in it. That's the greatest common factor. So we're going to take out an 8 and we'll get x squared plus xy plus x plus y. Okay. That's an x. All right. Using factoring by grouping, greatest common factor here is going to be an x with an x plus y left over. So we want an x plus y left over here. Now, as I mentioned yesterday, I don't technically need the 1 here, but I'm going to put it there because in the next step, I do need that 1. Otherwise, I'm lost in the woods and I don't get to eat the candy house or whatever. But anyway. All right. Any questions about that one? So that takes care of requests that came in from you folks. So now we're going to go on to section 8.2. Give me just a second here. And okay. All righty. Now, can you still see my whiteboard screen? Did I do that correctly? Excellent. Thank you very much. All right. So we're actually going to go back to chapter 5, which we haven't talked about this quarter. But again, if you took Math 85, or if you took a beginning algebra course, maybe in high school or something, you should have dealt with this process, but I kind of want to review it. Let's say we have something like this. X plus 3 times x plus 2. Okay. And we're asked to multiply. So we do what the book calls FOIL, and that is we do the first times the first, x squared. Then we do the let's see, outer times, so there's your FOIL, F-O-I-L. So the outer, and we get plus 2x, and the inner we get 3x, and the 3 times 2, the last we get 6. We combine like terms and we get that. All right. Do I need to review that process more, or is it coming back to you in terms of what's going on there? All right. What we're going to do today is we're going to, instead of going here, we're going to go backwards. We're going to take x squared plus 5x plus 6, and we're going to pull it apart. We're going to factor this trinomial. Now, recall a trinomial, just like a tricycle has 3 wheels, a trinomial has 3 terms. Okay, so we're going to factor this trinomial into 2 binomial, as in bicycle, as in 2 binomial factors. So this is a binomial, this is a binomial. We're going to go from here back there. Okay, now, obviously the answer is x plus 3 times x plus 2 because it's right in front of us, but the next ones, we aren't going to have the answer ahead of time. So let's look at the process. Where did this come from? That came from the first, right? So going backwards, this would go there. Okay. Where did the 6 come from? It came from the last. So that means this times this, these numbers have to equal 6. But I've got a problem, because if I couldn't see the answer, I'd be going, well, is it a 6 and a 1? Because 6 times 1 is 6. Or is it a 2 and a 3? Because 2 times 3 is 6. So I'm not really sure there, whether it's a 2 times 3 or a 6 times 1. Okay. Where did this come from? Well, it came from those, which any Australian soccer players there? Oi, mate. Okay, oi. So that is where the middle term came from. It came from the sum of the outer and inner terms. Well, here's what we can conclude from this. We know that this goes here. Then we know that these 2 numbers right there have to have a product that equals 6. But it could be a 6 and a 1 or a 3 and a 2. But they also have to have a sum that equals 5. So we're looking for two numbers whose product is 6 and whose sum is 5. Okay. So the product is 6 and the sum is 5. Well, let's try 6 and 1 and 3 and 2. What's the sum of 6 and 1? It's 7, so that doesn't work. What's the sum of 3 and 2? It's 5. So 3 times 2, the product is 6. 3 plus 2, the sum is 5. So plus 3, plus 2, and we're done. How do we know we're finished and we've done it correctly? We'll take our answer and FOIL it back together. X squared plus 2x plus 3x plus 6, x squared plus 5x plus 6, and it checks. Okay. Now, we're going to start all over with a new problem. In this one, we won't know the answer yet. Okay, so we've got y squared plus 4y plus 3. Now, these problems that we're looking at all are going to have the same characteristics. They're going to be in standard form, which means descending or decreasing powers of the variable. So we've got y squared, y, no y at all. Okay, so there's your decreasing powers. They're also going to have a leading coefficient of a 1. So there's like an implied 1 out there in front. So if there's a leading coefficient of a 1 and it's in descending powers, we know it's going to be split up that way. Okay. We're looking for a product that's equal to 3 and a sum that's equal to 4. Because remember, 3 goes here and here, and this number times this number multiplied give us 3, but then this product plus this product added together have to give us 4. Okay, so let's clean up that, get rid of all that extra stuff I just put there. Okay, so we're looking for a pair of numbers whose product is 3. Well, let's see, 3 and 1, and whose sum is 4. Well, what's 3 plus 1? 4. So there's the pair of numbers. Now, you might say, do I have to write it in that order, or could I have written it in this order? And the answer is yes, you could have, because multiplication is commutative. And since the first part of each factor was the same, we could do it in either order. Okay. All right. Any questions on this particular problem? Here comes another one. X squared plus 7x plus 10. This is a trinomial. It's in standard form, descending powers of the variable, and it has a leading coefficient of a 1. So it's going to get split up like that. I'm looking for two numbers whose product is 10 and whose sum is 7. All right. Two numbers whose product is 10. 10 and 1, 5 and 2. Okay, well, what's 10 plus 1? It's not 7. What's 5 plus 2? Bingo. So 5 times 2 is 10. 5 plus 2 is 7. So plus 5 plus 2. So there's our answer. Let's check our work. X times x is x squared. X times 2 is 2x. 5 times x is 5x. 5 times 2 is 10. Combine like terms, x squared plus 7x plus 10. It checks. So that is the correct solution. Any questions? Okay. Let's take a look at another one. C squared minus 9c plus 8. This is a trinomial. It's in standard form or descending powers of the variable c, and it has an implied leading coefficient of a 1. So we're going to have a c and a c in the front. The product is 8, and the sum is -9. Okay, not 9, but -9 because of that minus sign in front. Well, let's see. Two numbers whose product is 8. How about 8 and 1 and 4 and 2? But neither one of those pair of numbers add up to -9. Well, consider this. How can I get a positive product? I can take a positive times a positive, or I could take a negative times a negative and still get a positive answer, couldn't I? But since the sum is negative, it can't possibly be two positive numbers. So given that the product is positive, the two numbers have to have the same sign, because positive times positive gives you positive, or negative times negative gives you positive. But if they're both positive, I can't add them up and get a negative. So what I'm telling you is that I can determine ahead of time that my numbers have to both be negative. Are we okay with that? So now, what's -8 plus -1? That's -9. So that's the numbers we're looking for. This would give us -6. So -8, -1. We'll check our work, and then we're done. Okay, so this is c squared minus c minus 8c plus 8. Combine like terms, c squared minus 9c plus 8. This matches that, so the answer checks. How are we doing? All right. Okay, let's see here. A squared minus 10a minus 39. I have a trinomial. It's in standard form, descending powers of a. There is an implied leading coefficient of a 1. You're probably wondering, why do I keep saying all of that over and over? Because when things aren't that, then things are different. And then we have to do different things. Okay, so I'm going to split it up, a and an a. The product is -39, and the sum is -10. Okay, now, the last problem, we said that a positive times a positive is positive, and a negative times a negative is positive. But I've got a negative product. So that means I've got to have a positive times a negative, or a negative times a positive. Okay, so the signs of the two numbers have to be opposites or different. Okay, I'm looking for a positive number and a negative number whose product is -39. But when I add those two numbers together, I get a -10. Okay, well, let's see. -39 could be -39 and +1, or it could be 39 and -1, or it could be 3 and -13, or -3 and 13. I think that's all the possibilities. So all of these have the correct product. They all multiply together, give you -39. But which of them, if any, have a sum that's -10? This one. Now, notice something. My sum is negative, which means that the two numbers I'm looking at, the negative one has to be more powerful. So there's no way it would be that one or that one, because here the positive is bigger, here the positive is bigger. Okay, so what that tells me is I'm looking for a big negative and a little positive. Multiplied together, they'll give me a negative product. Added together, the negative will dominate and swallow up the positive, kind of thing. I don't know if that makes any sense, but it will help you to kind of narrow the field so you don't write a whole bunch of possibilities that you could determine ahead of time don't work. Okay, so we got 3, and minus 13. We're going to have a squared minus 13a plus 3a minus 39, combine like terms, a squared minus 10a minus 39. It matches, so the solution checks. You doing okay? Thumbs up? All right, good. Okay, let's see here. Now, this hasn't come up before today. That is in today's stuff. This is a trinomial. It's in standard form, descending powers. It doesn't have a leading coefficient of 1. It has a leading coefficient of a -1. So what we want to do is we want to factor out that -1 because it's easier to factor a polynomial when the leading coefficient is positive. So I'm going to rewrite it like this. Okay. Notice factoring out a -1 changes the sign of each term in the original trinomial. Now I'm going to take the trinomial that's in parentheses and split it up. My product is 20. My sum is -9. Notice I'm looking at this now. I'm not looking at this any longer because I've factored out a -1. So now I'm dealing with this new trinomial to get my numbers over here. Okay. Now, we've got that scenario again where we have a positive product. So it has to be a positive times a positive, or it could be a negative times a negative. But the sum is negative. So it's got to be 2 negative numbers. Okay, so I might try -20 and -1, -10 and -2, -5 and -4. There's my 2 numbers. Now, if you looking at it can see that, oh, it's this, you don't have to write all the possibilities. I'm just doing that saying, if you can't just see it, then write the possibilities and check them. This has got a sum of -21. That's got a sum of -12. Bingo. That's got a sum of -9. So -5, -4. And you could write the answer like this, or you could just put a negative sign out in front because there's an implied 1 attached to it in this context. All right. Good to go on? Yep. Okay. Let's see here. A squared plus 6ab plus 5b squared. That's a 6. Okay, now this is a trinomial. It is in standard form in terms of the variable a. It's not in standard form in terms of the variable b, but since it's good in a, we'll go with it. Okay, so I'm going to get a and a like that. My product is going to be 5 and my sum is going to be 6. To get a positive product, it's got to be positive times positive or negative times negative. Oops. But the sum is positive, so it's got to be 2 positive factors. Okay. So how about 5 and 1? Oh, 5 times 1 is 5. 5 plus 1 is 6. So plus 5 plus 1. Now, what have I forgotten? What have I left out? What's not there that needs to be? The b's. Okay. So how are the b's going to show up? Well, this is going to get pulled apart. So that's going to be a b, and that's going to be a b. I don't need to put this 1 there, so I can write it like this. Which reminds me of something that you're going to need to remember about web assign. Okay. There's really nothing wrong with putting an implied 1 coefficient in front of a variable. But in WebAssign, it doesn't recognize it, so it says it's wrong. And if you do that and I catch it, like on a test, if your problems are wrong, I always look to see what you've done. If you put a, if you put a 1 there and they say it's wrong, I would still mark it correctly. But people freak out when they get an answer wrong, when they think they've done it correctly. So watch out for that. You don't need to put the implied 1 coefficient in front. Okay. All right. We don't want anybody freaking out just yet. Okay, let's take a look at this one. 3y squared minus 21y plus 18. Now, this is a trinomial. It's in standard form, and it has a leading coefficient of, oh, it doesn't have a leading coefficient of a 1, does it? Is there something we could do so that it would have a leading coefficient of a 1? We could take out the greatest common factor, which is a 3. Okay, see what I did there? So now what's in parentheses fits the pattern. In fact, this is what I tell all my coffee drinking friends. I don't particularly like coffee. Caffeine and I don't do well. They'll say, well, how do you wake up in the morning? You like, how many cups of coffee? And I say, no, I just factor a couple of polynomials and I'm good to go. Yeah, so there you go. All right, now, again, I'm no longer considering that. This is what I'm dealing with. So my product is 6, my sum is -7. To get a positive product, I've got to have a positive factor times a positive factor, or a negative factor times a negative factor. But to add 2 positive numbers, you're not going to get a sum of -7. So my 2 numbers have to both be negative. How about -6 and -1? Well, yeah, -6 and -1, that does it. So I really didn't even need to go on. -6 minus 1. So there's the final answer. Now, how would you check your work on that? You could do it a couple of different ways. You can multiply in any order there. So I could take the 3 and distribute it and get 3y minus 18, and then take that times y minus 1 and get 3y squared minus 3y minus 18y plus 18. Combining like terms, 3y squared minus 21y plus 18. So that was doing this first. Or I could multiply those together first and get that, and then multiply the 3 through. Okay. Just like if you have 2 times 3 times 5, you could go 6 times 5, or you could go 2 times 15. Now, you follow what I'm saying? Multiplication. Okay. All right. Let's see here. How about this one? -m cubed plus m squared plus 56m. 56m. It's a trinomial in standard form. But it doesn't have a leading coefficient of a 1. It has a leading coefficient of a -1, and it's not like m squared, it's m cubed. So the greatest common factor would be an m, but I'm in fact going to take out a -m because I want to have a leading coefficient that's positive m squared. And then this is going to be minus minus 56. Okay. So now we're going to have an m there and an m there, and a product is -56 and a sum is -1. Wow. We've got a really big product, but a really small sum. So consider this. Because the product is negative, it can't be plus times plus or minus times minus. It's got to be 1 positive factor and 1 negative. Oops, I don't want to write a 1 there. let's do this again. I'm going to have a positive factor times a negative factor, right? One of each. But the sum, when I add those two numbers together, I get -1. So that means the negative is a little bit bigger than the positive, just one bigger in terms of their absolute values. So here's where, if you know your multiplication tables, this is going to be easier than it is if you don't. What times what is 56? Think of two numbers that are really close together that multiply together are 56. Anybody? 7 times, what's the other one? I can count fingers. 7 times what? 7 times 8. Good job. You did that without having to speak. Okay. So 7 times 8 is 56. But what if we made 7 and -8? That would give us -56, and the sum would be -1. So the two numbers, their absolute values are just one apart, but the bigger, the negative number has to be on the bigger number there, okay? So +7 -8, and there we go. Good job with your counting there. I was told that once I stood on the table, took off my shoes and socks and counted on my toes. I can't remember the experience, but I could believe that I would have done that. So, all right, let's see here. Let's take a look at this one. Y squared plus 100 plus 25y. This is a trinomial, but it's not in standard form. So we're going to rewrite it so that it is in standard form. Now, not only is it in standard form, descending powers of the variable, but it also has a leading coefficient of an implied 1. So we're good to go. 1 or y and y. Product is 100. Sum is 25. Any questions how I got there? Okay. Now, the product is positive, so it's got to be either two positive factors or two negative factors. But the sum is positive, so it's got to be two positive factors. Okay. So I know ahead of time I'm looking for two positive numbers. Let's see. 101, 50 and 2, 25 and 4, 20 and 5, 10 and 10. Do any of those look good? Oh, how about that one? Now, I'm going to go back and do this one again a little bit slower. There were quite a few possibilities there, and sometimes you might miss one of the possibilities just randomly putting them down there. So let's approach it slightly differently. Okay, we already know that they're both positive. So I'm going to start with 100 and a 1. That gives me the product that I want, 100. But the sum would be what? 101, right? So that's a long ways away from 25. Well, the first number is even. So if I cut it in half and I double the second number, half 1, double 1, I still get a product that's 100, right? But my sum is now 52. Well, that's not correct, but I'm getting warmer, getting closer. Well, let's see. 50 is even. Let's cut that in half and 20, and then double the 2. So I've got, So I've still got a product of 100, but now my sum is 29. Okay. I'm really close. Well, 25 isn't even, so I can't cut it in half. I also know that I'm getting closer and closer to 25, aren't I? So it's like this number is getting smaller, this number is getting larger, and I'm getting closer to 25. So it seems like I need a number here, put a little box there, that's smaller than 25, and a number over here that's larger than 4. Okay? Can you think of any number smaller than 25? Larger than 4? Well, how about 5? That's larger. 5. Well, that would have to be a 20. Oh, and there's your two numbers, right? So what I'm getting at is that if you just randomly throw numbers out there, you might miss it. Have a method of narrowing it down. You know, again, some of us will be able to look at that and just go, oh yeah, 20 and 5, and you're disgusted because they're getting it right and you're struggling with it. Well, if you're struggling with it, this is a way to get to the answer. It may take a little longer than your neighbor, but who cares about them anyway? All right. Okay. Hey, I shouldn't say that. They'll have extra time to watch Star Trek reruns. So plus 20 and plus 5, there's your two numbers. Okay. How about this one? X squared minus 9x minus 12. This is a trinomial. It's in standard form, descending powers of x. It has an implied leading coefficient of a 1, so it's everything we want in a trinomial. So the product is negative 12 and the sum is negative 9. Now, if the product is negative, I can't have positive times positive or negative times negative. It's got to be one of each, a positive and a negative, right? But the sum is negative, so the bigger number is negative. So we got a big negative and a little positive. Okay. So that means my two numbers, whichever one's negative, has to have the larger absolute value. So for instance, negative 12 and 1, I would consider. 12 and negative 1, I wouldn't even consider because the bigger one has to be negative. Okay. Bigger absolute value. So let's see. Negative 12 and 1, negative 6 and 2, negative 3 and 4. Oh, wait a minute. That couldn't work. And then what am I doing? I'm cutting it in half and doubling it because the bigger one has to be negative, but I could make negative 4 and 3, right? Okay. Well, let's see. What would this sum be? This would be negative 11. This would be negative 4, and this would be negative 1. But the number I'm looking for is right in there, isn't it? You still following? Don't fall asleep on me now. Okay. About 1 minute to go. So my pair of numbers to get my negative 9 has to be, one of them has to be between negative 12 and negative 6. So it could be like negative 11, 10, 9, 8, 7. One of them has to be between 1 and 2. Well, there are no whole numbers between 1 and 2. So what does that mean? This trinomial is prime. It doesn't factor under real numbers. What do you mean it doesn't factor? Well, let's take a look. Let's take the number 6. You could factor that into 2 times 3, right? How about the number 5? 5 is a prime number. It doesn't factor. Now you could say, well, I can write it as 1 times 5, but if you'll recall from your pre-algebra days, 1 is not a prime number, so we don't write it that way. So a prime doesn't factor. This doesn't factor, so it's a prime polynomial. Okay? So you're going to run across some problems where it may say factor the following. If it's prime, say so. Okay. If you just leave it blank, that's not answering it. You say, well, it wouldn't factor. You've got to declare to the world that it's prime. Okay. All right. So I'll be back at 1:15 with an office hour at a different Zoom meeting ID. You've got section 6.2 for tonight. That's due tomorrow. You've also got, if you're still working on 6.1, that's going to disappear at midnight tonight, just like Cinderella's coach turns into a pumpkin. So you want to get that done. If you can't make the office hour this afternoon, but you've got questions, I'll try to check my emails for that. And also, if you have questions you want me to do tomorrow morning in class, email me and request that, and I'm happy to do it. So I'm going to stop the recording. And